All right, GERO 200. Look, it's me. I'm still wearing the same Lakers t-shirt, so this must be the same day. And it is, okay? So this is, again, Sunday the 23rd, setting you up for your first week of class, okay? All right, and class will start officially tomorrow, Monday, the 24th of June, 2024. All right, so we're going to go straight into what? Module 2. Before we do that, we got to enter the class, okay? Awesome. And then we're going to go into getting into the modules, which it just depends on whatever way you like. Do you like the fancy way with the widgets? We could do it that way. All right, let's go into module 2. All right. All right. Very cool. Now, what I was trying to show last time, and it's very different because I am not a learner, okay? I am me, but I just wanted to let you know you can go into your grades before, right? Your grades, your quizzes, okay? I'm gonna do view as a learner right here, right? And then we're in, okay? We're just like you guys, all right? Now, ideally, I would be able to go in here and I would look at the quizzes and I would be able to see what it looks like, but things are not ideal right now, all right? So this is, if I was you, I would be able to click on it and I would be able to go ahead and do the quiz right here, all right? But it's not there, okay, because I'm not a student. All right, anyways, let's just go back to the home page here. And this time I'm gonna go back to the contents. Oh, got you. I'm gonna go to part 2, all right? I love the graphics that Julia's put in here, all right? This encapsulates everything right here. We have our set DNA, okay? Our recipe for life, all right? How awesome is that, all right? 23 pairs of chromosomes, all right? And they dictate, you know, the recipe for making every single protein in your body, all right? So 23 pairs, about 20,000 genes roughly, plus or minus a few thousand. And any one point in time, we're gonna mix it up, okay? Now, one way we have used epigenetics is as we develop, as we go from sperm, okay, egg, or they fuse, okay? Now we got to start going from a single cell to 2 cells to 4 to 8 to 16 cells, okay? And how those develop are determined by epigenetics, what proteins are turned on and off. And then you finally get to the point of an embryo and you're starting to make a liver and a kidney. We got the same recipe book, 23 pairs of chromosomes. What proteins do we make and when do we make them? That's epigenetics developmentally. And then once it's all said and done, okay, you're born and you're out there and you're doing your thing. Which ones do we turn on or off at any one point in time? And this is what we're kind of showing right here is based on your life experiences, okay? You can eat really well, you can exercise, okay? You surround yourself with good people, lots of love, okay? You continue to exercise and you see that late in life you're going to do well. You're going to do very well, all right? Turning on the right genes, okay? And then what we show here is, look, your children get those on and off switches passed on to them, which is awesome. It sets them up for success. That's the concept. And this is, you know, plus or minus, this has been shown. Or we can be the same blueprint, all right? We can look at twins, identical twins, okay? Start off with the same exact DNA. Instead, we're eating lots of orange soda, Coke, okay? Smoking cigarettes, eating fries, okay? Pizza. You're lonely. The toxicity turns on certain genes that are bad for you. You end up being disabled and sickly and die young, and that's passed on to your kids as well. All right, that's the essence of that, okay? So this lecture is going in right here, okay? And we can go in here and look at the readings and videos that I promise you are a lot more low-key this go around. All right. All righty, so it's up to you how you want to go about this, okay? Well, we have 2 different types of switches. One is methylation, okay? The other is called acetylation. The focus of what we're looking here in these genes, we're going to be looking mostly at methylation, but both are very real, okay? Methylation turns genes off, okay, for the most part, all right? And acetylation, okay, gives you access, that's how I remember that, to the genes, okay? So acetylation turns genes on. So there's a lot of cancer that is too many genes being turned on, and so there's a lot of interest in what are called deacetylation interventions that will turn off those cancer genes, all right? All right, so that's basically what this is all about right here, okay? And there's a whole industry out there that we have to be really, really careful of. You know, it is what it is. People will take a grain of truth and try and make millions and millions of dollars off it. It didn't used to be so pervasive in science, but it is very pervasive in science now. Somebody gets an NIH grant, it gets something that looks kind of promising, gets promoted by the public relations group from USC, and next thing you know, they form a company and they're trying to sell you some snake oil, all right, that supposedly is going to increase DNA methylation or reduce acetylation. Okay, yeah, there's a long history behind this, and I don't have time to get into it, but you have to be very, very careful. Okay, there's a group called Asylum Health. Okay, this guy David Sinclair that is under lots of scrutiny. That's all behind all this, and he found a compound that was a deacetylation compound that looked just like resveratrol found in red wine. He took the ball and ran with it. It's crazy, crazy, crazy. He actually sold the company to Eli Lilly for almost $1 billion. And then Eli Lilly got in there and tried to replicate the findings, couldn't. And they were left holding the bag. And he went off and formed a bunch of new companies. So you got to be very careful out there, sad to say. All right, so this video, okay, is actually embedded in this really easy to read article. So she, Courtney Griffins, gives you a real nice overview, just like I did, of what is the field of epigenetics and how that influences which genes are turned on or off. And a gene is just a recipe to make a protein. All right. So which proteins are put out there into cells and which ones aren't. Okay. And how that impacts the overall health and well-being of cells. She talks about stress, and that's a lot about what we're focusing on this part of the class. All right, so we have the PDF file right here if you can access it. Okay, this right here goes into the article. This is just backup for me. All right, so I'm going to go right into the article by the conversation. It's published in the conversation. Very simple, easy to read. As I indicated, her video is embedded in here. All right, so it's a little bit redundant. Okay, and so. It starts with a kind of review of what you saw when you watched the Sapolsky video for Module 1. And they talked about World War II, okay, and the infamous Dutch famine. So you can research more on this if you wanted, okay. It was a horrible, horrible, both psychological stressor during World War II, okay, lots and lots of stress hormone, and then the physiological stress of going through this incredible famine, okay. And they talk about how many people that had happened. They look at the calories that were being consumed during that time. If you look at the nutritional basis of the famine right here, so it was just remarkable. I had basically a fourth of the calories on a daily basis for a couple of years, and it took its toll. Okay, so then when these people were followed, okay, and they looked at things like their grandchildren, it shows you that their physiology was impacted, okay? Even though their mothers did better, okay? Some of these switches were carried on, and that's what that's all about right there. And they looked at the offspring of these Dutch women that went through the famine and much more likely to have neurological disorders like schizophrenia, all right? So that's epidemiology, where we just study populations. That is very suggestive. And then what you can do then is you can then do more interventional studies and see if you can reverse the trend, or you can do animal studies where you replicate it, let's say in a mouse model, right? All right, so this is the whole field of epigenetics, okay? And in terms of our health and our genetic makeup, which genes are turned on that can lead to bad physiology, which genes are turned off that protect us, okay? So that's what this is all about right here. And so they go through all the nurture versus nature, okay? So nature is our cookbook of 23 chromosomes, okay? Those are the genes that there's a Darwinian inheritance of genes, okay? It's very, very slow. And then there's the epigenetics. It's kind of immediate, and that's the nurture in terms of what has happened in your life history and what you're doing about it right now, all right? All right, so these markers, okay, these are stop and go signals in terms of what genes get turned on, okay? And there's this whole concept that you get this inheritance again across generations, okay, in terms of which genes are turned on and which ones are turned off. We know that it's environmental because we can look at identical twins, and we can. There are companies that will look at your methylation. This is a form of epigenetics, and it's a flag, they say, or it's a gene, whether the genes are turned on and off. Okay, so science has looked at that. Okay, and in identical twins, we can see, which ones led to obesity, depression, anxiety, even though they were genetically identical, based on the environment. So this is kind of a little bit more kind of statistical analysis looking at the epidemiology, all right? And then it gives us hope that this is something that we can then fix in the future, okay? And, for example, in pregnant women, what we can do in terms of their environment to make sure that their offspring have really good epigenetic switches. All righty, so that's the basics of that, all right? Okay, so those are the basic, that's where the quizzes come from. If you want to learn more, this is a really cool interactive website. It used to be even more interactive when it was Flash-based, and then, guess what happened? Flash disintegrated. Thank you, in terms of the new computer science, okay? But anyways, you can go into this website and you can study more, okay? For example, we can go in here, we can just look at the epigenetics at a glance, okay? It has a very cool video that shows you this concept of turning genes
DNA contains the instructions for building all the parts of the body.
So this goes to the development that I was telling you about.
But DNA is only half the story. The DNA in our bodies is wrapped around proteins called histones. Both the DNA and histones are covered with chemical tags. This second layer of structure is called the epigenome.
Right.
The epigenome.
So acetylation is what determines the wrapping. So when you remove the acetyl group, the deacetylation,
inactive genes,
it opens up.
Them
and then you got the methylation tags that have to be removed.
It relaxes active genes, making them easily accessible. Different sets of genes are active in different cell types. The DNA code remains fixed for life, but the epigenome is flexible. Epigenetic tags react to signals from the outside world, such as diet and stress. The epigenome adjusts specific genes in our genomic landscape in response to our rapidly changing environment.
Stress, sociality, all right, so you get the feeling, again, one of the key things that the narrator said is that the blueprint, all right, the DNA, the actual genes, is unchanged, okay? It is the same in every single cell in your body, okay? It's what you inherit. And then the tags, the epigenetic switches, are what vary based on nurture and environment. And you can inherit how they're turned on and off as well, okay? But the key concept is you can modify it, okay? All right, so that was just from right there. So you can do lots, you can look at identical twin studies right here, what was found. This is up to you. We can look at the inheritance right here. We can look at the nurture part right here. Really, really cool stuff. We can look at, this is the studies done in animal models that you can also look up right here. All right, very, 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 very cool. Okay, all right, guys, that's it for week one. Hopefully you guys have learned a lot, and hopefully I put your fears to ease. Okay, don't worry about this. You got it wired. Peace.